Hi everyone. Today we're going to learn about Boyle's law and Charles' law and how they relate to gases. So 10.4, Boyle's law. By the way, if you have any questions, please email me um, at that email shown there. Basically, the objective of this is you got to be able to use Boyle's law to describe and make calculations with the relationship between pressure and volume. Then just show what it looks like on a graph. So that relationship itself, that is actually what we're going to call Boyle's law. And it was come up with an English scientist. So Robert Boyle in 1662, he discovered that pressure and volume have an inverse relationship, meaning that when one increases, the other will decrease. So for this to be true, um, basically your temperature and your amount of gas that you have has to be constant. So as long as you keep temperature the same and the amount of gas you have the same, when you increase pressure, volume goes down. Or if you increase volume, pressure goes down. Um, and this relationship here is henceforth what we're going to call Boyle's law. So you can actually solve equations with this as well. This math equation shows exactly what's going on here. You have P1 times V1 is equal to P2 times V2. And P1 and V1 are just your initial pressure and your initial volume. So like, whatever numbers you have, put them in there and multiply, see what you get. And then right here it says P2 and V2 are your final pressure and volume. So normally you'll know one of those and then you'll be able to plug a number in there, and whatever is left over is just going to be some unknown like X, and you'll be able to solve for that. So some guided questions I'm going to do with you all here are, first of all, a student decreases the volume of a container while keeping temperature constant. What happens to the volume of the gas inside that container? Well, if you decrease the volume, inverse relationship says that you should increase the pressure. So pressure goes up. And I'm just going to write P up, pressure goes up. A chemist has a flexible closed container that contains 1 liter of gas at a pressure of 2 atmospheres. If temperature is kept constant, what happens to the volume of the container if the pressure of the gas is doubled? So you can do this in your head if you just remember that relationship. If pressure goes up, volume goes down. So if pressure is doubled, volume has to be going down at the opposite of doubled, which is halved. However, you can also use the equation that we just learned. P1 times V1 is equal to P2 times V2. So we're going to plug in what we know and then solve for our unknown. So our initial pressure, which we know, is 2 atmospheres. So I'm going to plug in 2 for P1. Our initial volume is 1 liter, which we also know. Then it says our pressure is doubled. So let's see, initial pressure is 2. So 2 times 2 is 4. That means our final pressure is going to be 4. We can plug that in. And then we're not given our final volume. So since we don't know that, I'm going to put in an X for V2, our final volume, which means we now need to solve for X. So if you're just using this equation, using some algebra here, if you're solving for X, you got to make sure it's all by itself. So if there's a 4 in front of X, got to get rid of that. Let's see, 4 times X, the opposite of 4 times X is going to be dividing by 4. So let's divide both of these sides by 4. By the way, 2 times 1 is going to be 2. So let's see, 2 divided by 4 is 1/2, which is equal to our new volume. You do have to use units here though, so I want you to make sure you use 1/2 of a liter as our new volume, or that could be 0.5 liters as well. Okay, these are questions I'd like you to try answering now. And I'm going to proceed to give you the answers to them after you've finished answering them. So describing Boyle's law in your own words, something as simple as when pressure goes up, um, volume goes down, and the other way around. Fill in the blank. As pressure decreases, volume increases. A student doubles the volume of an airtight container. What happens to the pressure of the gas inside the container? Well, it gets halved, assuming that all the other variables are the same, like um, temperature and the amount of gas that you have. Describe how you would draw a graph showing the relationship between pressure and volume. Now you can actually just draw it here, but I said describe because I'm only accepting text responses. But let's see, relationship between pressure and volume. So pressure and volume, and we know that as one goes up, the other goes down. So when you draw an inverse relationship on a graph like this, it's actually kind of this curved line that looks like that. And that's how you do that. Yeah, it looks right. Okay, moving on to the next section, 10.5, Charles's law. This is another what we call gas law. And what we're trying to learn with Charles's law is we're trying to now deal with the relationship between temperature and pressure. So that's the gist of Charles's law. And then try to graph that if we can. Temperature and pressure is Charles's law. Is there a good way to remember that? So what is Charles's law? Well, in the early 1800s, French adventurers became interested in hot balloons. It was a big hot balloon deal back then. Jacques Charles and Joseph Louis Gay-Lussac made detailed measurements on how the volume of gas was affected by the temperature of a gas, because I mean you have to make the hot air balloon expand. Given the interest in hot air balloons at the time, it was very easy to understand why these men should be interested in the temperature and volume relationship for a gas. So Charles discovered that volume and temperature have uh, proportional, this is proportional relationship or directly proportional relationship, meaning that when one increases, the other increases. And also the other way around. So if one of them decreases, the other one decreases. So for example, if I wanted to increase the volume and I'm able to, maybe to inflate this hot air balloon, I want to increase the volume of the balloon. Maybe I could heat up the air with like that little flame burner, right? And if I heat up the air, temperature goes up, so volume goes up and everything expands. So for this to be true, just making sure everything else remains constant. So pressure must remain constant. The amount of gas must remain constant. And whenever you're performing calculations with this, your temperature must be measured in Kelvin. So if you have Celsius, convert that over first. How? By adding 273 to that amount of Celsius you have. So there is some math here as well. To show a directly proportional relationship, you can just use fractions like this. So Charles's law, we say that volume and temperature are directly proportional. So you could say V1 over T1 is equal to V2 over T2. So again, that 1 and 2 refer to the initial versus the final. So sorry, these are supposed to be temperature and volume. So for example, volume, V1 is the initial volume, V2 is the final volume, T1 is the initial temperature, T2 is the final temperature. You can just plug numbers in and solve for what you have unknown, and you can easily find the answer that you're looking for using algebra. So over here, I'll do an example for you. The volume of a gas is 1.5 liters, and its pressure is 200 Kelvin. If the temperature is increased to 400 Kelvin, what is its new volume? Okay, so I'm already thinking I have to do some math. I have to think about this equation I just learned. So let's see, something like V1 over T1 is equal to V2 over T2. And I'm just going to think about what I know already. So V1, my initial volume, it looks like it's 1.5 liters. My initial temperature, I have to make sure it's in Kelvin. They gave it to me in Kelvin, thank goodness, is 200 Kelvin. So I'm going to write 200 K. And then temperature 2, is increased to 400 Kelvin, so basically doubled there. And what is going to be my new volume? So my new volume, V2, I don't know. I'm going to write X or question mark or something. So I could plug these numbers in and solve it with the equation, but I also want you to think about the relationship and what's going on here as well. So if temperature is doubled, temperature in Kelvin is doubled, then you already know that the volume is going to be doubled as well. So 1.5 times 2, that's going to be 3 liters as your answer. Now I want to show you how you use this equation as well. We should be getting 3 liters. So let's just plug these numbers in. V1, so 1.5 liters over T1 over 200 is equal to unknown volume X over, and then plugging in 400 Kelvin. Okay, solving for X, we need to get this 400 out of the way. So make sure we multiply both sides by 400. Cancel out the 400 on the right side. So 400 divided by 200, we can already cancel a lot of that out. So it's going to simplify to 2 times 1.5 is equal to X. So 2 times 1.5 is 3. And you do not forget your units on your final answer. That is 3 what? 3 liters. Okay, and these are the questions I want you to solve. So take a moment, make sure you solve them, and then I will continue the video in order to give you the answers. So the volume of a gas is 10 liters and the temperature is 1500 Kelvin. If the temperature is decreased to 750 Kelvin, what is its new volume? So I'm just going to do shortcuts here. 750 compared to 1500, the temperature got halved. So if the temperature is halved, then I know that my volume is also going to be halved. So what is half of 10.0? That should be 5.0 liters as our final answer. I used 2 sig figs because we had 2 sig figs with our other numbers. Number 2, the temperature of a gas is 100 Kelvin and its volume is 500.0 milliliters. If the volume increases to 1000.0 milliliters, what is the new temperature of the gas? So again, another shortcut, we can see the volume doubles, so the temperature in Kelvin should also double. So instead of 100, I'm going to write 200 Kelvin. Really nice, easy relationship here. Finally, describe how you would draw a graph representing Charles's law. Well, if one variable goes up, I know the other variable goes up. So generally temperature is the one we can control. So I would put temperature as our x-axis and then volume as our y-axis. And we know that as one goes up, the other goes up. So you can just draw a straight line going to the upper right. And that's how you draw that graph. I believe that's all we have for these 2 little lessons. So make sure you have those questions answered. You submitted everything you need to submit. And let me know if you have any questions. Thanks for watching.